The next topic in this lesson is the number of solutions of a linear system. So, although this is called a linear system of equations, if you were to graph the equations, you would not graph a line. What would you graph? You'd actually graph a plane. When you graph three planes, here's what it could happen. All three planes intersect in one point. If that happens, then what you have is a system that has one solution. But it could also happen that the three planes intersect in a plane or in a line. When that happens, then there would be an infinite number of solutions. It can also happen that the three planes are parallel or they intersect in multiple lines. Then there is no solution. Since I'm not very good at drawing all of this, we're going to take a look at the illustration in our book. So all those cases are being illustrated on page 522. Three planes that intersect in one point, one solution. Three planes that intersect in a line, an infinite number of solutions. Three planes that intersect in one plane, so the three planes coincide, an infinite number of solutions. The planes intersect in three lines, no solution. The three planes are parallel, no solutions. So those are some of the cases. So we could either get one solution, no solution, or an infinite number of solutions. What we're going to do right now, we're going to take a look at example 4, which illustrates an inconsistent system of equations. We're still going to use Gaussian elimination. We're going to take a look at the top row, and we're going to be really happy. Why are we happy? The coefficient of x is just 1. So, first goal is achieved. What's our next goal? Get rid of the 2x and get rid of the x from the second and third row. To do so, take row 2 and add negative 2 row 1 to it. And that will give us our new row 2. Take row 3 and add negative 1 row 1 to it. And that will be our new row 3. Let's do that. So row 2, 2x minus y minus 2z is equal to 2 plus negative 2 row 1. That will be negative 2x plus 6y minus 2z equals negative 2. Let's check just to make sure. Negative 2x plus 6y minus 2z equals negative 2 is correct. Let's add 0x plus 5y minus 4z is equal to 0. So this is our new row 2. Let's find our new row 3. New row 3, we're going to do row 3 plus the opposite of row 1. So row 3, x plus 2y minus 3z is equal to negative 1 plus the opposite of row 1, so plus negative 1 times row 1, the opposite of x plus 3y minus z is equal to negative 1. Let's check. So first row times negative 1, negative 1x plus 3z minus z minus 1. Everything is good. Let's add no x's. 5y's minus 4z is equal to negative 2. Like I said, this is our new row 3. Let's rewrite. We have x minus 3z. 3z, no, 3z, 3y. So x minus 3y plus z is equal to 1. 5y minus 4z is equal to 0. And 5y, is it minus 4z, is equal to negative 2. Right now, you should stop and think about this. It is impossible for 5y minus 4z to equal 0 and 5y minus 4z to equal negative 2 as well. Yes, I know what I told you. Yes, I know we're supposed to get a 1 as a coefficient of y, but this problem is so easy to do right now. I'm going to skip those steps and I'm just going to say row 3 plus the opposite of row 2 is the new row 3. Why just do that? Well, if I add row 3 to the opposite of row 2, I will be able to eliminate the y's. So, to save some time, I'm just going to do that. So, let's do it. Row 3, 5y minus 4z is equal to negative 2, plus the opposite of row 2, negative 5y plus 4z is equal to 0. Add them. 0y plus 0z is equal to negative 2. You get 0 is equal to negative 2. This is a false statement. So this is false, which means that your system is inconsistent. In other words, there is no solution. No solution. And so we're going to stop right here. Like I said, if we wanted to prolong this, we would now take, so let's say that we did not notice that the coefficient of y is the same, we can just get rid of it. If we did not notice any of that, it's not a problem. It is a problem, I mean, it's going to take longer. What you do next is just say 1/5 of row 2 is the new row 2, and you continue working until you've eliminated the y's from row 3. I'm going to stop here. I already know that there's no solution to this system.